Hi, my name is Brittany Fleming. I am a microbiologist, and this is Sofa Science. Thank you guys so much. I want to invite you into my living room. I'm so excited to get to talk to you about some of the research I've been doing. But first, as this is Sofa Science, I need to introduce you to my sofa. So let me just kind of turn you around. So this is my sofa. It is actually a futon. I bought it used. We got it from this really cool place that specifically sells used furniture in order to raise money to fight child abuse. So it's kind of cool to get to help that, but also get this really awesome sofa that's just really comfortable and kind of springy. And I'm excited to kind of just sit and chill and get to talk about one of the things I love most, which is science. So, as I said, I am a microbiologist. So, this means I study living things that are so tiny we can't really see them with our eye. So, this includes things like fungus. So I've been lucky to study a fungus called Aspergillus fumigatus, and it lives in our soil, and you can breathe it in, and sometimes it can cause a lung infection. There's a great group at Utah that studies the fungus Cryptococcus neoformans, which also you can breathe in, and it can infect your lungs and spread to your brain. Ooh. Another fungus, not quite so deadly, is ringworm, which we can get from our playgrounds and playing in the playground. Another parasite is another kind of tiny living organism that's a microbe. I think a lot of people may know of malaria. There's also like hookworm and roundworm and tapeworm. And then, of course, there are viruses. So I studied a virus called the human rhinovirus, which is a cause of the common cold. There's also influenza virus. And, of course, I think a lot of us are familiar with now the virus that causes the disease COVID-19. But of course, my favorite microorganism are bacteria. And I'm really excited to get to share with you the really awesome things that bacteria do. And so this is a fun little picture that my boss actually took. And it's bacteria that are adhered to urinary tract cells. And so I am most interested in bacteria when we are at war. I am really interested how the bacteria can kind of infect and invade us and make us sick, and how we fight back. And so we have this really amazing system that's called the immune system. That's kind of our little army that responds when bacteria invade us. And they kind of come and run and charge, and they can release a whole bunch of toxic substances that can really lead to the death of bacteria. But don't worry, bacteria have their own kind of tricks kind of up their sleeve, their own arsenal that can help them fight back against the immune system and survive. And that's really what I'm interested in, is understanding how bacteria are able to survive while they're infecting us. And so one of the biggest infections that we see, especially like in an outpatient setting. So this means if you go to your doctor's office, are urinary tract infections. And about half of all biological females will have a urinary tract infection in their lifetime. I mean, I feel like that is just so freaking crazy. 50% of biological females will have a urinary tract infection in their lifetime. And it's not just really a one and done. A lot of biological females who get a urinary tract infection will get another one relatively soon after that first. And what happens is, unfortunately, you have patients who will get a urinary tract infection after urinary tract infection after urinary tract infection. And in my work, I've been able to work with a patient who unfortunately has had urinary tract infections for over 25 years. So my friend June, let's take a look into her bladder and see potentially what the bacteria are doing. So this is June's bladder, and the bacteria come and infect, and of course, our army, the immune system, comes to fight back, and they release a bunch of their weapons to try to kill the bacteria, and in some cases they are successful. But in some cases they're not. So let's look and see what these three bacteria do to kind of survive in the bladder. So the first thing they do is what I like to call kind of hide and seek. And basically what the bacteria do is they kind of come and like knock and enter the cell that lines our bladder. And so they can kind of come and make this nice little cozy home for themselves. And they kind of hide out in our cells to the fact that when they have invaded our cells, the immune system can't find it. Another common tool that we use to fight infections are antibiotics, right? These are drugs that help us kill off bacteria. But when the bacteria are inside our own cells, the antibiotics just can't reach them. And so here the bacteria is hanging out. It can kind of grab nutrients from its cells, so it's pretty great. And soon it starts to replicate, and it replicates, and he replicates. And soon there's an overwhelming number of bacteria within the cell, and it kind of bursts out, and you kind of start reinfection, and they can start replicating and infecting new cells, and they kind of just start the infection all over again. So the next thing that bacteria do are what I like to call playing dead. Basically, what they can do is they can pretend they're dead. They go to sleep. They're what we like to call in science persister cells. And when these cells are dormant and we take antibiotics doesn't kill them, right? It thinks it's dead. And so when we're done taking antibiotics, and if it's killed off all our other friends, this bacteria can kind of wake up, start replicating, and start the infection over again. But I feel like I've painted kind of a rosy picture, right? That the bacteria have just a great time. But in fact, really with the immune system and with other things, it's a really stressful environment. And they are just trying their best to survive. So let's take kind of a closer look into one of these bacteria to see what it's doing to survive all this stress within the bladder. And so bacteria, just like us, and so one of the stresses that I study, especially when you think about the bladder and urine, is high salt. And you can get some pretty salty urine, especially during a bladder infection. And high salt actually is not good for bacteria. It's pretty dangerous. And so they have to be able to respond to it. And so DNA, just like us, has this great blueprint, right? It has, this great blueprint about how to respond to different things. And so in times of high salt stress, it makes RNA, which is messenger, which can then make protein. And it's the protein that responds to this high salt stress that helps the bacteria fight it off or just survive it, just to be able to live. But sometimes that works, and the bacteria is just like, whatever, you throw your things at me, I'm going to survive. But sometimes that protein doesn't work. So what does the bacteria do? Is it just out of luck? We actually hypothesize that it's really doing this really cool technique called frame shifting. So what is frame shifting? So we have our blueprint, right? It says, who are you? And it's 3 different genes that can become protein. They make sense, right? They're words. They become protein and they can go and fight and do what they need to do. But sometimes when who and are and you aren't working, the bacteria wants to get a little sloppy, right? It starts maybe sliding. It's like, well, we have all these letters, maybe we can make different words. And so it kind of moves one to the right. And you get hoa, re, au, which really aren't words. But then you go maybe one to the left. And now you get or. Or is a word. Maybe or can help us fight the stress. So it's kind of like that. So what the bacteria do in times of high salt is they get a little sloppy and they start making protein. And maybe they make some more protein. And they even make even more different types of protein from that one messenger. And that protein didn't work. And these proteins definitely don't work. Ugh, those don't either. But this protein, this one protein that we made by being a little sloppier, this helps them survive against the high salt. And this opens up a lot of questions for us. The first is whether frame shifting is programmed or random. Whether, maybe or is actually encoded in our DNA. And we don't just have one messenger to one protein, but maybe we have one messenger to 3 proteins, right? And so it's a multiple, we have lots of levels. The other question that we ask is it all RNAs or is it specific RNAs? So those messengers. Does it happen to every messenger the bacteria is making at the time? Or is it just the messengers that we know go on to make proteins that respond to stress? Some other questions is is this frame shifting communicable? So we know this bacteria found a protein that can help it respond to high salt. But remember, the bacteria is a soldier, an individual soldier in an army of bacteria, and there are lots of its other bacteria around it. So can it communicate to another bacteria, hey, guess what? Use this, it lets you survive. We don't know. Can it be heritable? Can it be passed on to their offspring? And so there's a lot of questions, and we're really excited to kind of delve in and understand if frame shifting is a valid way the bacteria are responding to stress, and then what that means. So that's it about this project. But I just want to say thank you so much for listening. I love science because I love being at the forefront of understanding life and getting to ask the questions I'm interested in. And I really want to encourage you. To keep learning about science, to keep asking questions, to really look into the research community in your community and think about maybe some experiments you can do. And of course, I have to recommend that you visit one of my favorite places, which is the Natural History Museum of Utah, to go and learn about science, but also they're just a great resource to learn about the scientific community in Utah. And they also have cool dinosaur bones.